In an announcement that has sent ripples through the global scientific community and ignited imaginations across the planet, NASA and the European Space Agency have just released the clearest and most detailed image ever captured of Proxima B, Earth's nearest potentially habitable exoplanet. Captured by the James Webb Space Telescope, this moment represents not just a triumph of technology but a turning point in humanity's quest to find life beyond Earth. Proxima B, long veiled in obscurity and scientific speculation, now stands revealed, not just as a candidate in a list of possible exoplanets, but as a discernible, dynamic world with real geography, atmospheric features, and climate patterns. Nestled just over 4 light-years away in the Alpha Centauri system, Proxima B orbits a red dwarf star named Proxima Centauri, the closest star to our Sun. Since its discovery in 2016 through radial velocity measurements, analyzing the gravitational tug it exerts on its star, Proxima B has remained a planetary enigma. We knew it was roughly 1.2 times the mass of Earth, and we knew it orbited within the star's habitable zone, the region where temperatures might allow for liquid water. But until now, we had never seen it, only inferred its presence through indirect data. That has now changed forever. The image, unveiled during a joint press conference between NASA and ESA, is breathtaking. Unlike previous attempts to visualize exoplanets that relied heavily on artist renderings or light curve extrapolations, this is real observational data. Refined through infrared and thermal imaging, and painstakingly processed to subtract the overwhelming glare of its host star, the image reveals actual surface and atmospheric characteristics. For the first time, we are looking at another rocky world in the galaxy with unprecedented clarity, one that may, under the right conditions, support life. But this image is more than a photograph, it is the result of decades of technological evolution and scientific perseverance. The James Webb Space Telescope, a marvel of modern engineering, orbits far beyond the Moon's gravitational influence at the Lagrange point 2, L2, a gravitationally stable position in space, perfectly suited for deep space observation. Unlike its predecessor, the Hubble Space Telescope, Webb doesn't operate in visible light. Instead, it detects infrared radiation, allowing it to cut through clouds of cosmic dust, peer into stellar nurseries, and isolate the heat signatures of distant exoplanets. When Webb turned its 6.5-meter segmented mirror toward Proxima B, it wasn't just hoping for a glimpse, it was aiming for a revelation. And a revelation it was. The image reveals gradients of thermal variation across Proxima B's surface, evidence of an active planetary environment. Some regions appear darker and cooler, possibly indicating nightside regions, ice caps, or high-altitude cloud cover. Others shine with the dull warmth of sunlight absorption, suggesting rocky plains, perhaps even landmasses or desert-like surfaces. Subtle differences in heat patterns suggest a possible weather system or atmospheric dynamics. For the first time, we're seeing not just the outline of a planet, but the personality of a world. This information also allows for deep spectral analysis. By dissecting the infrared light bouncing off and radiating from Proxima B, scientists can now identify atmospheric gases with unprecedented precision. Preliminary results are encouraging. Early spectra show the possible presence of carbon dioxide, methane, and, most intriguingly, water vapor. Although it's too early to confirm definitively, this discovery fuels the tantalizing idea that Proxima B may have a thin but stable atmosphere. If true, it would make it one of the most Earth-like exoplanets ever discovered. The atmosphere of Proxima B has long been a subject of fierce debate. One of the biggest challenges facing rocky planets orbiting red dwarf stars is stellar flaring. Proxima Centauri is known for its frequent, violent solar flares, which can strip away a planet's atmosphere over time. But Webb's observations hint that Proxima B may be protected. Whether by a robust magnetic field, similar to Earth's, or by the sheer density and chemical makeup of its atmosphere, the planet seems to be holding its own. This is a game-changing insight. Previously, such planets were largely dismissed due to radiation concerns. Now, they may be reconsidered as viable abodes for life. One of the most profound mysteries surrounding Proxima B has been the question of tidal locking. Given its close orbit, just 5 cents from its star, it's likely that one side of the planet constantly faces Proxima Centauri, while the other remains in eternal darkness. Such conditions might result in extreme temperatures, too hot on one side, too cold on the other. But the new image and data challenge this assumption. The terminator zone, the area between night and day, shows a smooth heat gradient, implying effective atmospheric circulation. Warm air may be moving from the sunlit side to the dark side, potentially creating a twilight ring where conditions are stable and tempered enough to support life. This eternal dusk zone may be the Goldilocks belt within the Goldilocks planet. Adding to the excitement is evidence of geological variety. The image doesn't just show a monochrome sphere, it hints at topography. Variations in surface reflectivity and temperature may indicate rocky highlands, plateaus, or depressions. Some scientists even speculate, though cautiously, that such features could be volcanic in origin. Volcanic activity could supply the atmosphere with critical gases, regulate surface temperature, and even create conditions for the development of subsurface liquid water, a key ingredient for life. The spectrographic hints of hydrated minerals are particularly tantalizing. While not direct proof of oceans or lakes, the presence of such minerals typically results from long-term interaction between rock and liquid water. If Proxima B ever had surface water, or still does, then the planet may have undergone geochemical processes akin to Earth's, possibly even creating environments suitable for microbial life. Water vapor detection in the upper atmosphere could also point to an active hydrological cycle. Could there be rain? Could there be clouds? Webb's data suggest it's possible. This image doesn't just deepen our understanding of a single planet. It redefines how we explore the universe. For decades, the search for exoplanets was largely statistical. We knew they were out there, but we couldn't see them. Now, we can. The leap from indirect detection to direct observation of a rocky, Earth-like world is one of the most profound in the history of astronomy. It opens the door to observing other nearby terrestrial exoplanets, including those in the TRAPPIST-1 system, and refining models of habitability across the galaxy. Proxima B has now transitioned from theoretical target to visualized destination. No longer just a wobble in a star's spectrum, it is now a planet we can see, study, and imagine ourselves reaching. This image lends fresh momentum to Breakthrough Starshot, the ambitious initiative to send nanocraft to Alpha Centauri within our lifetime. If a tiny probe traveling at 20% the speed of light were launched today, it could reach Proxima B in just over 20 years. Until now, such missions were dreams. Now, they feel like plans. But beyond the science and engineering, this moment is deeply human. For the first time in our species' history, we've captured a detailed image of a potentially habitable alien world. That's more than a scientific milestone, it's a moment of cosmic introspection. Astronomers, biologists, philosophers, and everyday people alike are grappling with what this means. Is Proxima B empty, waiting to be discovered? Or is it alive, quietly evolving in its sunlit silence? The image has sparked emotional responses among scientists. Some have likened it to the iconic pale blue dot or the blue marble, photos of Earth that changed our perception of home. Proxima B, in all its strangeness, evokes that same sense of awe. It is not Earth, and yet, in its contours, colors, and mystery, it feels oddly familiar. It forces us to consider that Earth may not be unique, that planets like ours may be scattered throughout the stars, each one a potential cradle for life, for stories, for civilizations. This image may also influence future public funding and education. Schools, science centers, and documentaries are already preparing new materials to teach children not just about Earth, the Moon, and Mars, but about Proxima B. It is the first exoplanet many people will see with their own eyes, not as an artist's impression, but as a real place. That psychological shift, from imagining to observing, may be one of the most powerful outcomes of all. So what comes next? Webb will continue observing Proxima B in different wavelengths, building a time series of data that can reveal seasonal changes, atmospheric shifts, and even potential surface events. Future telescopes, such as LUVOIR and HabEx, will one day dwarf Webb's capabilities, allowing us to capture full-color, high-resolution images of Earth-like exoplanets. In time, we may even resolve continents, oceans, and cloud systems. But this image of Proxima B will always be remembered as the moment we truly saw another Earth. In closing, the James Webb Space Telescope has done more than photograph a distant world. It has bridged the gap between dream and discovery. It has expanded our horizon, not just in light years, but in understanding. It reminds us that the universe is not cold and distant, but rich, dynamic, and perhaps, just perhaps, teeming with life. Thank you for watching. If this video stirred your sense of wonder, please like, subscribe, and join us as we continue exploring the farthest reaches of space. Let us know in the comments, what would you name Proxima B if we one day land there? Until next time, keep your eyes on the stars.